Okay, we're broadcasting, so we're going on to the quiz. I know, it was so weird this week with having the test thrown in there that, and I have another account, I have an accounting test too, so kind of,
Yeah.
I'm sure everybody.
I have a econ test this week too, and it's been kind of brutal this week.
Yeah.
Crazy.
I have to take that at some point.
Yeah.
For me, it feels like I have a test every week. Last week I had a bio class test, and like anatomy.
Oh. Yeah, I'm lucky. I already had anatomy and physiology, a full year of it.
Oh
Yeah.
Yeah, that class wasn't easy either.
A lot of
Well, and if you're having stuff online, I think that it's really a lot harder. I don't know, but I've had online classes, and these at BYU Idaho are the hardest online classes I've ever had.
Yeah.
Yes. And I've had quite a few online classes at different colleges.
I've never taken anywhere else except for here.
Yeah, there's so much work in this class, in these classes. But anyway, okay, let's go. Are we ready?
Yeah. Question 3. Which hypothesis involves equality?
The null hypothesis?
Yes.
Oh, yeah.
I did learn that much.
Yeah.
Yeah, me too.
The p-value is the probability of obtaining a sample statistic at least as extreme as the one that was actually observed. Use this info to answer the next question.
Oh.
Remember that
that's not a true false, sorry.
Remember that the p-value is the probability of obtaining. We just read that. Okay. When computing the p-value, which hypothesis do you assume to be true? The null. Wait, no.
The null. Wait.
When computing the p-value?
Yeah, the null hypothesis, yeah. That's right.
Yeah.
Oh, because it gives you either or.
Yeah.
Suppose the null hypothesis is H0 mu equals 10. Use this information to answer the next 3 questions. Which of the following represents the alternative hypothesis for a two-tailed test?
Okay.
Two-tailed. Oh, it's not equal to.
Yeah.
Right.
Yeah.
Not equal to.
Okay. Number 6. Which of the following represents the alternative hypothesis for a left-tailed test? So left-tailed, that means
the first one.
Less than.
Yeah.
Wait, so mu is less than?
Yeah.
Okay.
Yes, less.
For left, less, and then for right, it's greater, I think.
Yeah, this time it makes sense. The right and left skewed doesn't make sense.
All right. Number 7. Which of the following represents the alternative hypothesis for a right-tailed test?
That will be B.
So
It's greater. Okay. Remember that we determine the outcome of a hypothesis test by comparing the p-value to the level of significance, or alpha. Use this information to answer the next two questions. Number 8, which relationship would result in failing to reject the null hypothesis? Okay.
Hang on a second.
I'm gonna look at this stuff.
If the P is low, reject the null.
So we should say no.
So it would look at number, do you have your homework with you? Or the preparation? If you look at number 7, number 10, part 7. No, I'm sorry, 6.
Number 6?
Yeah. He, the guy who was doing the video, he mentioned something about this, like if you, if the P is low, reject the null. And in that one, 0.83 was greater than 0.05, which was before the test. And then after the test, the p-value was 0.83. He said, you failed to reject the null. Is that the same thing?
I don't know.
That would mean that the p-value would be greater than alpha. Okay, let me take a look at her.
Okay. Would the p-value be less than alpha? Sorry, I'm just looking back through. So it says if the p-value is less than a, we reject the null. If the p-value is greater than alpha, we fail to reject the null hypothesis. Maybe I don't have that right.
Where's that at?
I have. It was in the reading.
I thought that was what I said, but that's why I was asking, like, isn't
I know,
that what?
Again, I was trying to figure out what exactly our question is now.
I think
P-value is greater than the level of significance, which is that alpha, right?
Okay. Yes.
That's what I'm seeing in my notes. Okay.
Okay. Yeah.
So if the p-value is less than?
No, it's greater than.
greater than, because we are failing to reject. And
If we
now have
fail-
got this-
Failing, so if the P is lower, you reject the null. If the P is greater, then it's a failure to reject the null. I guess I'm saying that right. I don't know.
Yeah, so the first
we can
one.
change it if we need to.
Yeah, I think it's the first one.
Ah, that's right. I just couldn't find it until just now. Okay.
Okay.
All right. Number 9.
Yeah.
Which relationship would result in rejecting the null hypothesis?
So that would be the opposite.
Yes.
Yeah. P-value is less than alpha. An insurance company reviewing its current policy rates. When originally setting the rates, they believed that the average claim amount was $1,500. They are concerned that the true mean is actually higher than this. Use this information for the next two questions. Which of the following would be the appropriate alternative hypothesis? Actually higher.
Yeah, so
Greater.
that it's greater than 1,500.
Mm-hmm.
Yeah. Number 11. Which of the following would be the appropriate null hypothesis? The average claim is equal to 1,500. Okay.
Yeah.
Yeah, if there's no effect or no difference, that's the null hypothesis, I'm thinking.
Yeah, because like the null hypothesis is the only one that's equal to
Right.
Yeah.
the insurance company randomly selects n equals 40 claims and calculates a sample mean of x bar equals 1650. Use this info to answer the next 3 questions. The insurance company assumes the distribution of the sample mean is normal. Is this a good assumption?
It's large because look at that.
Yeah, it's large. Yeah.
What does it say?
Because it says that n is equal to 40 claims, which is less than 30, right?
Yes.
Yeah. Yeah, I was just it's like the other one that says
It's normal.
it's
I think it's
yeah, because the population is already normal, but it doesn't say that, so yeah.
What? Sorry.
Oh, you're right. I think you're right. It's a good assumption since the sample size is large.
Yeah, that's what I also think.
Yeah.
Yeah.
Okay. Number 13. What theorem or law justifies your answer to the previous question?
It's central. Because it's the one that says that if it's large, then it's
Oh.
I just don't want to be wrong. Right? You
Wait,
getting out your notes? Is that what you're doing?
me.
I am. I'm getting out my notes. So.
But if it doesn't, sorry. I think I'm mixing things up.
All right.
Okay.
That's the. Did you guys say central limit theorem?
I'm thinking that it's just that they use almost the same terminology. Yeah, because they're not talking about the population mean. They're just talking about the sample size being large. So that's central limit.
Yeah.
Yeah. Okay. Number 14. Which of the following is the test statistic as defined in this lesson?
Um,
That wow. I don't have that phrase anywhere. I've got what? The test.
Oh, I think it's Z.
Z?
Maybe. Yeah, somewhere it said like the probability of obtaining a test statistic such as Z.
Yeah. D4.
Oh.
10D4. Recall our test statistic will be a Z-score. Yeah.
Oh, okay.
Yeah.
Good job. You have such a good memory.
Okay. The historical mean of sales receipts at a grocery store is $150 with standard deviation of $40. The store manager suspects that the average has decreased. She sets up a hypothesis test with the hypotheses. Mu equals 150, and then the alternative mu is less than 150. She will use a level of significance of alpha equals 0.05. She then takes a simple random sample of 36 sales receipts from her store and computes X bar equals 144. Number 15, what is the z-score associated with this test?
Okay. I think I can do that. Oh, gotta get out my calculator. To get like 0.8999.
I don't know if I did that wrong, because I just got negative 0.9.
Negative 0.9 will work. Mine, I didn't know how many 0.6s to put in.
Wait, where?
Oh,
I'm gonna do it again. 115.
does it say to put your decimal to round to 3 decimal points though?
I know.
Okay, let me try it again. So it's 40 divided by 6, right? 6.1, 2, 3, 4, 5, 6, 7, 8, 9. Got 9 6s and a 7. Yeah, it's 0.900.
Okay.
If it's not, I
Wait, negative?
Yeah, it's
negative.
neg-
Sorry.
Okay. Yeah.
Sorry,
So,
Nick.
wait, how many numbers are zeros are we gonna put after the
I
Just
put
put-
2.
Yeah.
we're just gonna say negative negative 0.9.
Doesn't matter.
It does say round to 3 decimal places, which is making me question my answer. Because, but I don't know. All right. Number 16. What is the
They all
p?
say that.
What?
They all say that though, so
That's
it'll
true.
be
Yeah. Okay. What is the p-value associated with the z-score from the previous question? Oh, okay.
I forgot. You have to. Oh, you plug in your z-score in the applet. Okay.
Value is like the probability
I thought I had my applet up.
looking for.
I got 0.184.
Let's see here.
Yeah, you're just doing the left side, is that right?
Yeah,
It goes to the right too.
I think it goes.
No.
Oh,
Well,
you mean shading it in?
That's only if it's a two-sided thing.
Right. What was
Because
it?
in the little thing, it says that she thinks that it's decreased. since she's already said that.
That
If she had just said that
the
she's
left side.
then it would be both
Yeah.
sides, but
So it's just left side, right?
yeah.
Okay. 0.184.
Yeah.
Yep.
Is that negative still?
No.
No.
Okay. No,
Yeah.
because it's the area. Okay.
Okay. 17. What inference would you make about the null hypothesis for this problem?
Gosh.
I don't know. Oh, okay. So we look at the level of significance, right?
Right. Was it 0.5, 0.05?
0.05. And compare that to the p-value?
Yes,
Or-
after the test, right, is
0.9. So it means that
the
So the
p-value
the
is
p-value is greater.
so it's
0.14.
rejected.
If p is low, reject the null. If it's larger, you fail to reject the null.
It's larger, right?
Yeah.
Yes,
Fail to reject.
I'm gonna fail to reject the null.
Okay.
Yeah.
Okay. Number 18. What is your conclusion for this problem?
Oh gosh.
We have insufficient evidence that the true population mean is less than 150? Or no? I don't know.
If
We have insufficient. Or we have sufficient evidence that the true population mean is 150.
Okay, so in the example on our homework, the p-value was larger than 0.05 and we failed to reject the null. The next one is state your conclusions. And the conclusion was we have insufficient evidence to conclude that the, whoops, what happened to, oh, it's in my hand here. To conclude that the mean age of people buying a second home is different in this area than that of the national average of 47. And I got to go back to the original question.
Yeah.
I think this is just my thought. We have insufficient evidence that the true population mean is less than 150. Wait.
Yeah.
That was what she said. She thought it would be less than 150.
150, yeah.
Yeah, but we failed to reject that. Which means
What does that mean?
so that means that the null hypothesis could still be true, but I don't think you can ever prove that it's actually true. But you don't have enough evidence to say that it's not true.
Okay.
So I don't know.
A,
I think it would be that.
I mean, from what you just said, and you always have the best ways of putting things. I think that sounds right to what you're saying, and it kind of makes sense. So
Yeah.
let's
Because-
put A, and then we can go back and revisit it if we have to.
Wait, which one are you putting?
Oh, I thought you said A. We have insufficient evidence that the true population mean is 150.
Oh no. Well,
No.
I
that's.
think it's the third one.
I think it's the third one.
Well, that's the one that I said.
It is. Yeah, and I thought I agreed with you.
No.
I thought you were arguing with me. Like,
No,
okay,
I was
yeah.
just talking to myself. I don't know.
Okay, so you think it's C?
Yeah.
Okay. Whichever, and we'll reevaluate if we have to.
Yep. 19. There are two types of errors that can be made when performing a hypothesis test. Which one involves rejecting the null when the null hypothesis is true? I have to look at my little chart.
Oh, I hate this one. I hate these.
So what is it?
No.
Rejecting the null when it's true.
Yeah, when it's true, I think it's type 1.
Type 1.
That's
Yeah.
one.
Yeah.
Yeah. Does everyone agree?
Yeah.
All right.
Yeah, I guess. I'm not really firm on these type 1 and type 2s, but
Sure.
just from my notes, I think that's right.
Okay. Number 20. A researcher decided that instead of using a level of significance of alpha equals 0.05, he will use alpha equals 0.01. Which of the following will be true? Okay, so if it's he's lowering
Yeah.
the level of significance,
Yes.
which would mean
Doesn't it increase the thing?
It is the probability. Let's see. A number to the level. Let's see. It is probably the probability of making a type 1 error, possibly. When
Why?
the p-value is small enough to reject the null hypothesis. I'm gonna opt out of that answer just because I'm looking at my notes from the video. Okay, look at part 2, number 9, C.
Okay. Let's do it.
If we, let's see. If we wanted to decrease the probability of making a type 2 error, we would need to increase or decrease the level of significance, then that would be increase the level of significance. So I'm thinking it's a probability of a type 1 error will increase. Not 100% on that.
Yeah, maybe. I'm gonna read. I'm reading something. So I don't know.
Reading? Okay.
Yeah,
Yeah,
just.
You take your time.
Wait, are you talking about part D? Or part C? Oh wait, okay.
On number 9 of the homework of the preparation, part 2, C. Yeah.
Yeah, but then also in part D it says like if we wanted to decrease the probability of making a type 2 error, we need to increase the level of significance. So for a type 1 error, I don't know.
Even increasing the significance, making it type 2.
Okay. Yeah. So what we're doing is we're decreasing the level of significance, right? From a 0.05 to a 0.01, or that's not an increase, right? So if we want to make it a type 2 error, we would increase the level of significance. If we want to make it a type 1, what is the probability? Let's see. So the probability at a 0.01 level is 1%. That 0.01 is the percent, is the level. I don't know.
I'm kind of lost, but I don't know. We can go with where you guys think.
I'm trying to wrap my head around it, trying to think of it.
What did you say, Brooke?
I'm just trying to wrap my head around it. I'm trying to
talk it out.
Yeah, I'm just looking at it. I don't know.
I mean, could it be like C, like the probability that the null hypothesis is true? No, wait, that wouldn't be right.
No.
No, that would be right. Okay.
Well, I hope we can rule out D.
Yeah.
D is out.
I think it's between A and B.
Yeah.
Okay.
I think B.
You said you think B?
Yeah. But what we can do is that maybe we can have half of the people do A, half of the people do B. I don't know.
Well, and then we could know for sure that was one or the other, right?
Yeah.
Okay. So I have A marked. I'll just leave mine a day.
Okay.
I'll just mark the B and C. We'll take it from there.
Yay, we're on the last question.
Yeah.
Well, second. Oh wait. Oh, that is the last question. Woo. Okay. Number 21. If sorry, my throat is kind of. If alpha equals 0.05, compute the probability of committing a type 1 error.
Oh.
That's weird.
Let's see here.
Okay.
The probability of computing a type 1 error. Well, the probability of computing a type 1 error will be 0.05. I know it doesn't make sense. Oh my gosh.
And it very well could be.
Because it says that compute the probability of committing a type 1 error. Well, the probability of committing a type 1 error is 0.05. Well,
Well, what
But
does the alpha represent? That's the level of significance.
yeah.
Right.
Yeah.
So we're looking for the
probability.
probability or the p-value.
Do we have to make a z-score first?
Um,
Do we have a mean? Do we?
my mind doesn't want to work anymore.
Yeah.
Okay.
Oh my gosh. Angela may be right.
Yeah, because we don't have sufficient information on this.
Right.
Yeah.
Just have 0.05. That's the only thing that we have. And the previous question has 0.01. So I thought maybe it's 0.05. That is the probability of committing an error one type.
Yeah. I mean, that makes sense from what I have on my homework. So,
Okay, guys. That is right. I went ahead and submitted it because I figured, why not? Let's look at what it is.
It's 0.05.
Yeah,
So
so it's 0.05. And on question 20, it is a type 2 error. Will increase.
Sweet.
and
And the
And then
rest
it's
of them.
100%. So,
Nice.
we
Oh
got
my
the rest of
gosh.
them right.
yep, we got the rest of them right.
I feel like
Wow.
some of that is just luck.
Yeah.
It is.
I just kind of wanted to know, so I went ahead and just submitted.
Thank goodness. Whew.
Yeah. Less stress now, guys.
Yeah.
Okay. Now we just have one more. I swear, all the quizzes. Oh my gosh. Still have to do one more lesson 9 quiz. Ugh.
I know.
Okay.
100%.
Well, good job, everybody.
Yeah.
Good job.
Today.
Oh gosh.
We might want to keep that. All right.
All right.
And so next week, what do you want to do for meetings?
I don't care. Do you guys like doing Tuesday, Thursday, or Monday, Wednesday? It's either way.
Either way is fine for me.
Yeah. All those
mean-
days would work for me. Either, yeah, I can make those times work. So.
I mean, if you want to go to family night, by all means.
Yeah, and also on Wednesdays I have institute, but
Oh,
well,
yeah.
it's at 7, so I usually just go and then I like bring my computer and then do it there. But
Oh,
yeah,
well,
Tuesday, Thursday would work like a little better for me, but I don't
yeah.
care.
Well, we can do Tuesday, Thursday. That'll be fine with me.
Yeah, that'll be fine.
Okay.
Okay.
All
All
right.
right. See you next Tuesday then. Good luck this weekend.
Thanks. Okay.
Yeah.
Bye.
All right.
Bye.
Bye.